Somebody sent a chat. But it's being recorded here. It's being recorded. It's only mean that somebody asked for permission to record. I'm recording it. It's being recorded here. It's making us. Uko, Otter, please move. Yeah, they are chatting. Anyway, I will attend to the chat after the lecture. Somebody was asking for the recording. We are recording is on the YouTube, on the website. You can have access to it. We'll discuss that immediately after. Let's just commence the lecture.
I'm so cute. Oh, I'm going to end this bag.
Okay, I think we can start now. We're just distracting, looking for a place to. Okay. Yeah, you are welcome once again. Today we'll be discussing measures of association. We started the discussion last week, Thursday, and though we couldn't finish, but with the look of things, for the turnout today, it's like more than people that attended last week, and it will be good also to quickly browse through so that everybody will be on the same page. But definitely we'll quickly finish up today so that by next tomorrow we may discuss stratified analysis or logistic regression. But all of them are related. And the reason I want to discuss this is because of the stratified analysis and logistic regression, because the concept of odds ratio is very, very important. Understanding the concept of odds ratio from ordinary level before you talk about how it is useful in logistic regression. And that is why I decided to discuss with us measures of association. Now, the objective of the lecture is for you to understand concept of risk, odds, then understand relative risk and odds ratio. Then, well, for the workshop, people that have attended workshop that we attend, how to run, calculate relative risk and odds ratio with SPSS. But you know that before we even talk about how to calculate with SPSS, we usually solve with hand also. But we're going to look at the formula today, how the logic behind it. It's not just the formula. But one of those things, one of the cardinal principles of my lecture and training is for you to learn statistics without being bogged down in equation. Now, then how do you interpret? Because you get to know that if you want to publish in Lancet, nobody takes p-value from you. They want odds ratio, confidence interval. If you are comparing means, they want difference between means and confidence interval. So nobody wants to hear about p-value. But of course, here we still present the two, because we know that if you present only your relative risk and odds ratio, and you didn't put the p-value there, the examiner may not even know how to interpret the odds ratio. So that would be to your own disadvantage. And that is why we put the two, but it's like repetition. So we want to quickly move on. I want us to compare risk and odds. Risk just means probability. So we are familiar with probability, the chance of an event occurring is probability. Probability is the same thing as risk in statistics, but the everyday usage of risk may mean different things. Sometimes people think risk is only when bad things happen. You see, you are taking risk. So they are also talking about probability, but they are talking of the probability of bad things happening. You see, if you are traveling at night, they say, you are taking risk. They are talking of the probability of the person having unforeseen occurrence like accident or bandit attack or whatever. Issue there is that risk doesn't have to be bad. Risk is probability. Though some people also that get involved in portfolio investment, they know that people that gamble also, they know that when they put money, they either lose the money or they gain. There's no neutrality. So that is why they call their own speculative risk. That is, it's talking of probability of anything opposite. A can happen, B can happen. It's the probability. So just know that risk, in terms of statistics, is probability. Now, odds, the way it is related, or both of them, or it is related to risk, is that odds is risk divided by 1 minus risk. Risk means probability of an event happening. Then, if you want to calculate the probability of the event not happening, that should you remove it from 1, because probability is from 0 to 1. 0 means the event cannot happen. 1 means the event is certain to happen. Now, you cannot have more than 1. Probability cannot be more than 1. So it ranges from 0 to 1. So the probability of an event happening is a complement probability of the event not happening. If the probability of it raining today or tomorrow is 0.4, the probability of it not raining will be 0.6. That is 1 minus 0.4. It's like saying the probability of it raining tomorrow is 40%. The probability of it not raining 100 minus 40, making 60%. So you see, the probability of it not happening is a complement of the probability of it happening. And the odds is the ratio of the two. So what it means that if the probability that it will rain tomorrow is 0.6, which is 60%, the probability that it will not rain tomorrow will be 0.4, which is 40%. The odds of it raining tomorrow will be that probability of it raining tomorrow minus probability of it not raining, which is the 1 minus. So for that case now, it will be the odds of it raining tomorrow will be 0.6 divided by 0.4. So the probability for you to calculate odds, Lillian, sorry, I'm trying to stop the person. Dr. Lillian, mute yourself. So the risk of it is probability of it raining divided by probability of it not raining, which means 1 minus probability. That is why odds is risk over 1 minus. Some people, I will just remove them automatically because I don't know.
Mrs. Ozumba is disturbing the class, so my children.
I'll mute her, please. I'll mute her, Prof. I'll mute her. Because it's like you are in public lecture, you are in the public. It's not only you, so you have to be careful or you distract further. So now, if you do some mathematical manipulation also, change of subject of formula, you will see that risk itself also is odds divided by 1 plus odds. They leave that one, they just know, once you know this first one, that is the most useful. Because most of the time, you try to calculate odds from risk. On few occasions do you calculate risk from odds. But just know that odds of an event happening is the probability of the event happening, minus probability of the event, or divided by the probability of the event not happening, which is 1 minus event happening. And that is why you go to see the table on the right side, you see the values of some probability, which is the risk also, and the odds, corresponding odds. You will notice the reason, you will see the reason. Many people that try to bet for, maybe for sport, they use odds rather than probability, because the probability has a narrower range, whereas the odds has, you can say, from 0 to infinity. Let's look at it now. Look at this table. You can easily see it for yourself. If the probability is 0, risk odd will be 0. Probability here is the risk. So if probability is 0, the first one, odd will be 0, because you take 0 over 1 minus 0. 1 minus 0 will be 0. And 1 over 0. Sorry. If you say 0 over 1 minus 0, it will be 0 over 1. 0 over anything is 0. If you increase, as you increase the probability small, the odd also increase. But you see something. You know the probability is from 0 to 1. So that if probability is 0.5, that is halfway. Because something ranges from 0 to 1. If it is 50%, halfway, the corresponding odd is 1. Can you see? You can conceptualize it. If the probability is 0.5, that shows that odd will be 0.5 divided by 1 minus 0.5. So that will be 0.5 divided by 0.5. That will be 1. So when probability moves halfway to 0.5 halfway, the odd has doubled its own journey. It has the probability has moved. It has moved to 1. When probability, look at it, when probability is 1, you yourself, you can try and calculate it. If probability is 1, odd will be 1 over 1 minus 1. 1 minus 1 will be 0. Or anything over 0 is infinity. So when the probability finishes its own journey to 1, odd just started its own journey to infinity, to this space. So the range of odd is from 0 to infinity. So you see, that is you can see the odd of a corresponding probability is usually bigger in value. As the probability increases, the odd increases geometrically. So that is why many people, they prefer, using odd to bet, to predict, because if you are trying to compare 2 events, or maybe compare 2 teams winning, if you try to mark out all the chances each of them have, you will now see that when you use odds, you can see the difference. It will be big. But when you use risk, because the risk probability, the value is narrow, the range of value is narrow, you will not see different more than 0.8, 0.9. It look to you, it may look the same. But if you calculate the corresponding odd, you will see the big difference. And that is why, if you see, look at the table, the next below, below this one, you see odd is equal to probability of the event over 1 minus probability of. That's what we have just discussed now. Now, this is just a picture, a pictorial view. Probability. If you have a circle, a sector of the circle is the probability if you remove the event happening. So the probability, if the event happening is that red sector, the probability of the event happening will be that sector over the total. Because if you say probability of event happening is 4 out of 10, 4. The probability, if you say the chance the event happening is 4 out of 10, it means 40%, 4 over 10. If you look at it, 4 divided by the total, including the 4 itself, form the denominator. But if you look at odd, it's not like that. If the odd is this sector, it's divided by the remaining sector, that is 1 minus the probability. So that's why odd is probability over 1 minus the probability. And there's something, if the event is rare, like a disease is rare, the value of probability and odd approaches, they approximate. I'm going to see that also. When the disease is rare, odd ratio approaches relatively. You will see, look at this table now. When probability is 0, odd is 0. When probability is a little greater than 0, odd is greater. But it's greater than probability, but the distance is not far. But as the probability increases, the difference between their value increase, the difference between the probability value and the odd increases also. So when the event, the probability of an event occurring is very rare, the odds is closer to the probability than when the event is common. When the event is common, the odds is far, far away from the probability, that is from the risk. I think we have gotten some logic now about relationship between risk and odds. Now, let's quickly look at the relatively, the reason we're here. The measures of association we are talking about here are the relative risk and odds ratio. So there's third one that is close to them also, but we will not discuss it here, is hazard ratio. We rather discuss that under survival analysis, because in survival analysis, the outcome of interest is time before an event occurs. Time till event occurs. So the hazard ratio has to do with related to survival analysis. But it's the same concept, somehow. Now, when you hear the word ratio, I like the first principle. For some of us that we did physics in secondary school, you remember when they say ratio. Ratio is the quantity, what you get when you divide two quantities of the same unit. When both of them are, because when you divide them, you put the unit together, the unit will cancel. So what you now have has no unit. For example, if you say that somebody's travel 400 kilometers in 4 hours, when you divide 400 kilometers by 4 hours, it gives you 100 kilometers per hour. That is the speed. It's not a ratio because it has unit. The numerator is the kilometer. The unit of the numerator is kilometer. The unit of the denominator is hour. So the answer will be kilometer per hour. But if you are trying to compare, okay, somebody travel 400 kilometers, another person travel 4 kilometers. You now divide 400 by 4. You now get 100 is not 100 kilometers. It's not 100 kilometers. It's just 100. That's the ratio because the kilometer has cancelled kilometer when you divide them. So when you talk about ratio, know that it's division. And what you are dividing are the same quantity of the same unit. So that unit. So we have many of them. Like all these odd ratio, relatively, Z-score, correlation coefficient, those are ratio, you encounter them. And when you look at them, they are universal in the sense that they don't have unit. It is used in engineering, it's used in medicine, used in social science, in any field. Now, when we say relative risk, no, we are talking about risk is probability of event happening. Relative risk just means that probability of event happening in one group relative to it happening in another group. You're like if you say the probability of one person passing exam compared with another person passing the exam. You are comparing the two. And the way you compare it, you divide. When you divide, if you say, oh, the chance of somebody passing exam, you want to divide it by the chance of another passing exam. If you are able to divide, if it is 1, that should have both of them have the same chance. Because it is something of the same unit, of the same value, that have the same value. That when you divide them, it give you 1. 35 over 35 is 1. 1 million over 1 million is 1. So anything you divide, if both numerator and denominator are the same, it will be 1. So if the chance of somebody passing the exam and the chance of another person passing the exam is the same, when you divide them, give you 1. But if the one you put at the numerator is bigger, it will be greater than 1. If it's greater than 1, it now give you 2. That shows that person at the numerator is 2 times more likely to pass than the other person you put at the denominator. That's just it. If you divide it, if the numerator is smaller than the denominator, it will be 0 point something. It will tell you that the person you put at the denominator is more likely to pass than the person at the numerator. So that is the logic behind relative risk and odds ratio. You try to calculate the risk of an event, like a disease happening in one group. You now divide it by the risk of the disease happening in the other group to really see if the disease is more likely to happen in that group especially the one you feel you have the disease more happening is the one you put a numerator. And that is why when you are doing it in health, you look at people that are exposed to the factor, people that are exposed, that are exposed to the factor that cause the disease. You put them at the numerator to see what is the probability of disease happening among them. The ones that are not exposed, we put it at the denominator. What is the probability? If actually that particular factor is causing the disease or is contributing to the disease, the person that is exposed, you are put as the numerator, should have more value, more risk than the person you put as the numerator. When you now divide it, you give you how many times. If it's 3, that shows that it's 3 times bigger. I think the risk is higher, 3 times higher among the people that are exposed. So the logic behind both relative risk and odds ratio, both of them are ratio. So forget about whether they call this one. As you're going to see later, relative risk also can be called risk ratio. Odds ratio also can be called relative odds. So it doesn't really matter. So relative means that you are comparing the two. Ratio means that the way you compare it is by dividing. And it's the same thing. The only thing that risk is different from odds. Now, when do we use, before we go, when do we now use this tool? Why should we decide to use risk ratio or relative odds? Why should we use relative risk or odds ratio? Why should we use, what are the conditions? Now you will notice that it has to, in fact, the reason has to do with the nature of the risk and the odds. I think I even first talk about that. I'll come back to that one, to the slide. Now, the nature, in the sense that, number one, odds, you can only calculate, you prefer to calculate odds, not that you can only. You prefer to calculate odds when you cannot calculate risk. So the issue, to be sincere with you, what you want to measure is the risk of the event happening, and the risk of the disease. But there are situations where you cannot measure risk. If the event has occurred, you cannot measure risk. Somebody should making noise. Everybody should move. Now, if the disease, if event has occurred, you cannot measure the risk. You know, it has rained today. Now, say, what is the probability that it will rain today? What is the probability that it will rain today when it has already rained? So you cannot calculate the risk, which is the probability if the event has occurred. It doesn't make sense. But of course, you can see what you should do. You calculate something that you can calculate if the event has occurred. You will now calculate what you can calculate odds. After all, you calculate odds from risk. So if the risk has already passed, you calculate the odds. So in a situation where what you want to measure, like a disease, in a situation if the disease has occurred, like in case control now, we calculate odds because you cannot calculate risk. Because you have the cases, you cannot say what is the risk that this person has already have varicose vein. You say, what is the probability that you have varicose vein? What's the risk of varicose vein? The person has already gotten varicose vein. The person that is exposed now, that has not gotten, you can be talking, what is the risk of varicose vein? Don't know you get it now. So in a situation where, you know, most of the time in health, you want to measure association between the exposure and the disease. So if the disease has occurred, you cannot measure, you cannot calculate risk. So forget about relative risk or risk ratio. Forget about anything risk, because the event of interest has occurred. Like that is why when the only option you have is to go and calculate odds. I'm not talking about odds ratio with case control study, with cross-sectional study. Because cross-sectional study, you just go there, you measure everything at once. both the disease and the outcome. Whatever, either you want to know, okay, want to study obesity and hypertension, you go there, you measure blood pressure, you measure BMI, measure height and weight and calculate BMI at the same time. And you are saying that hypertension contributes. So, but the issue is that anybody that's hypertensive there has already gotten the hypertension now. So you are not actually calculating the risk of hypertension. What you are just calculating is the odds that this person that is hypertensive was the person obese. So you can see case control study, cross-sectional study, you can only calculate odds, you cannot calculate risk, because whatever event of interest might have occurred. Now, I have forgotten that because now the other way, cohort study, experimental design, because you look forward. You want to in cohort study, you gather people that are exposed and people that are not exposed. You are seeing in future how many of them will develop the outcome of interest. In that case, you can calculate. We are talking of, yes, the event has not occurred at the beginning of your study. The event has not occurred at the beginning of your study. In that case, you can set out to calculate risk. Experimental design, the same thing, because in experimental design, you do something, you still come to measure. You want to see what you even do. Does it have effect? You don't know that it's the risk you are looking for, either good or bad. No, so risk is not only about just 1 minute, just 1 minute. Yeah, sorry. Somebody was just distracting me here. So, yeah, sorry. Somebody's machine is echoing my voice. Somebody's machine is on. Everybody should mute. Joyce Edo Cabin, you are the one. Yeah. Okay, let's just proceed. So, experimental design, cohort study, you are looking to the future at the beginning of the study, so you can as well calculate the risk. So you don't have issue with calculating risk in those studies. However, even in situation where you can calculate risk, you can as well calculate odds. So you can see now odds is like more universal now. So you can calculate risk in some situation. You cannot calculate risk in some situation. But you can calculate odds in all situations. So the most accurate you want to actually what you are interested in measuring is the risk. So in that case, you calculate risk when you can calculate risk and calculate odds when you cannot calculate risk. But there are still some situations that also warrant you even calculating odds in a situation where you can still calculate risk or calculate odds together with the risk. For example, now, if you conduct cohort study and you can use your relative risk, you can also as well calculate odds ratio, because if you want to look at factor, do some analysis that require you analyzing factors that are responsible for analysis of factor using something like logistic regression. The statistic of interest is you got to calculate is odds ratio. So in that situation, even if it is experimental design or cohort study, after you have calculated your relative risk, you still calculate your odds ratio. So it's possible. So I was trying to look for the person that was making noise. Yes. Now, just to move further with this slide, you will see this line in the middle is now, is the present. Towards the left is the past.
Oh.
Towards the right is the future. Now, you will see in case control study, because the event has occurred in the past, what you are trying to capture information on what happened in the past.
The phone is just because of us calls that are coming.
Who is making noise? You know where people. Okay. Let's proceed. Now, you will see that towards the left, you see something like case control because the event has occurred. So every information you are looking backward. That's why they call it retrospective. You are being retrospective. Every information you are gathering is what has happened in the past. You are trying to gather. It's not future. You are not getting any futuristic information. It's what has happened in the past. But there's another type of course. Even the course study, even though most of the time you look forward, but there are some situations where you still conduct course study, you still look back. But it doesn't mean that you are calculating hurt, you are calculating risk. But what really happens is that though the event has occurred in the past, but there was a record of the exposure to the factor before the event occurred, and there was a record of the event also. So what we are trying to do was to use the record of the exposure. Maybe some people initially happen is more possible in occupational health, where in the industry, there's record of people that work there, people that were exposed to particularly people that work in dusty area, and they are, and they were okay by that time. So for how long? Maybe somebody was there for 40 years ago, was exposed to the factor, but 20 years ago, he developed lung cancer. So can you see now, there was a gap between 20 years between his exposure and development of the outcome of interest. But both of them are in the past. So you are still looking at it retrospectively. But it's still cohort study because you have information 40 years ago, you have information about people that were exposed and people that were not exposed. And you also, after 20 years after, which is 20 years ago now, you have information about people that developed the disease and people that did not develop the disease. So it's still cohort study, you still calculate your relative risk. But you are being retrospective in gathering your data. That's why they call it retrospective cohort. So case control by nature, everything about case control is retrospective. But we have prospective cohort and prospective cohort. Clinical design is usually prospective because before anybody can say he's doing clinical, you know it's not observational study. You know that case control and retrospective, they are observational study, while clinical trial is an interventional study in the sense that you are doing something. While in case control and cohort study, you are not intervening. You are just studying people in their natural place. You don't give people cigarette to smoke and say you want to see if they want to develop. You cannot perform experiment with that, but you can conduct observational study. From what I'm just coming back to this slide, from what we are just discussed now, you see, odds ratio is used when occurrence of an event where it has occurred in the past. But there's another thing. If you remember, I said that at the beginning that when the disease or the outcome of interest is rare, the relative risk in odd and probability, which is risk, are very close. You called me. Just 1 minute. Just 1 minute. Sorry. Henrietta, mute yourself.
Sorry. Henrietta, mute yourself.
Yeah. Okay, let's just continue. Yes. So the case control study one, in odd ratio rather, is used in situations where you cannot calculate risk. Then you can use it when you can calculate risk, so I've said it. But you may use also when the disease is rare, because when the disease is rare, the value of odds ratio and relative risk will be very close. Just like the value of odds and risk will be very close. So when the disease outcome of interest is rare, the value of odds ratio and relative risk will be very close. And you know that the type of study that warrants you calculating relative risk, like cohort study, experimental, they are very expensive. Cohort study is the most expensive type of study because it requires follow-up for prolonged period of time, and it requires money. And you can even follow up for 30 years, and you may only see few cases of the disease. You may not be able to make any meaningful analysis. So because cohort study is very costly, so using it to even study rare disease is a waste of energy. You just spend money for nothing. And because nature, God has made in such a way that whenever the disease is rare, even the odds and the risk will be almost the same. So another way, the relative risk and the odds ratio you calculate will be the same. So when the disease is rare, you calculate odds ratio also instead of relative risk. So you carry out case control study, calculate odds ratio, or you carry out cross-sectional study and calculate odds ratio. So I think those are the two examples. Case control, cross-sectional, analytical. When we say analytical, when we say cross-sectional, it's not just cross-sectional one group. Though people see, you can see how one group and split in and say and calculate odds ratio, because if we are running logistic regression, it brings out a one group, you can calculate it. But when we are talking of analytical study, most of the time, if you are testing hypothesis, you generate hypothesis with cross-sectional study, but you test hypothesis with analytical study. Analytical study is a study that have comparison group. That's all. There are more than one group you are comparing. That is, the group may not be physical subject. It may be group of observation you carry out. It may be from the same group of subject. But you are taking measurement more than one time. That's why all experimental design are analytical, because there is no experimental design without taking measurement more than one time. So case control study, cohort study, all are analytical study because we have comparison group. Cases control, so you are taking measurement at least on two occasions, though from different group. Cohort study, case control, then what they call comparative study, which people call cross-sectional analytical, but that's not the only cross-sectional analytical. Comparative study, there are two groups. Just give to you.
I don't have any $4.
So I think we move forward. Now, comparing risk and odds using two contingency tables. So we have discussed much now. How do you do the calculation? How do you actually do the calculation? Now, for you to do that, it usually comes in two contingency tables, 2x2 contingency table. And that is why they say the epidemiologists, they see everything from the eyes of 2x2 contingency table. The reason is very simple. They make it easy. You have exposure. You now divide into two, exposed, not exposed. Even if the exposure is in a form of continuous variable, you can have a cutoff where anybody that have above this is exposed. Below this, not exposed. But most of the time, it may not be. It may be like smoking. It's either you are smoking or not. So two possible value of exposure. Then the other one, outcome, either the person has it or not, two also. So both the outcome and the exposure are two possible values, and that make it 2 by 2. So we have 4 cells. So when you look at it, and by convention, you make the exposure, you put the exposure along the horizontal and put the outcome along the vertical. So when you do that, look at this table now, you see that exposed, not exposed. Then that's along the horizontal. Event occur, yes, no, along the vertical. So you see A, B, C, D. So each of the cells has its own address. A is different from B, so that is why it's good to know that. And that's the convention. Now, if you look at how do you get odd ratio out, I prefer you, rather than playing with A over B. There's an example, make it easy for you to understand. Instead of talking about A and B, let's look at live example. Look at an example to explain odd ratio. No, is it odd ratio? No, relative risk. This one we explain it. You can see both of them, but this one actually for relative risk. Can you see? This is 2 by 2 table. We have the exposure of the exposure here is smoking. Those people that are smoking, they were 500. So this one is look like an example of cohort study. This is an example of cohort study. 500 smoke or are smoking. Then two that are not smoking, 1,000. So the total is 1,500. So you have a study of 500 people smoking, 1,000 not smoking. You follow up. At the end of the follow-up, 30 out of the 1,500 developed lung cancer. The remaining 1,470 did not develop cancer. Now, out of these 30 that developed lung cancer, how many were exposed? How many were not exposed? 25 out of the 30. Okay, let's make it like this way. Out of the 500 that smoke, how many developed lung cancer? 25 out of the 500 developed lung cancer. And 475 did not develop. Then out of the 1,000 that did not smoke, 5 developed lung cancer.
Did you on the socket?
Yes, I did.
You have won the DSTV. Yeah, nobody should want anything today.
So 995 did not develop lung cancer. So now, if you want to look at it, very simple. The relative risk, you know that you are comparing risk among the people that are exposed to smoking. You want to divide it by the risk among the people that are not exposed. The risk among the exposed will be, out of the 500 that are exposed, the risk will be 25 that develop over 500. 25 divided by 500 is the risk of lung cancer among the exposed. Then, among the non-exposed, 5 out of 1,000, 5 divided by 1,000 is the risk. So relative risk now will be the risk among the exposed divided by the risk among the non-exposed. Simple. So it's like a way of saying this 25 is the A. The cell is the A. Then this 475 is B. 500 is A. And that is why the risk there is 25 over 500, which is A over 1, A plus B. Because the addition of 25 and 475, these two cells make all the 500. So A over A plus B. Then the risk among the non-exposed is 5 here, which is C over 1,000. 1,000 is 5 plus 995, which is C plus D. So the risk among the non-exposed is C over C plus D. So when you now A over A plus B divided by C over C plus D, if you substitute now, it gives you this, and if you change, division, is changed to times, the numerator changed to denominator here, and it gives you 10. 10. The risk, the relative risk is 10. This other one just calculates the odd ratio, but leave that one. We explain the calculation of the odd ratio, the other example. The other example, I explain the calculation of odd ratio. In this case, the same lung cancer and smoking. Here, instead of the way we started in the other one, we know how many people are exposed, how many people are not exposed. That is the nature of cohort study. Because by that time, the disease has not started and occur when you start to study. You only know those who are exposed, are smoking, and people that are not smoking. So it's from there, among the people that are smoking, you calculate how many people develop lung cancer now. Among the people that are not smoking, how many people develop lung cancer now. But for case control study, a typical example for the odd ratio, look at what you start with how many people have lung cancer first. That's why they call it case and control. Now, 200 patients treated in hospital, 50 have lung cancer. Of these patients, 45 are smoker. Of the remaining 150 patients, 60 are smoker. What is the odd ratio for smoking? Now, here, we are starting with lung cancer, 50 have lung cancer, 150 did not have lung cancer, the total is 200. Now, if you look at it in the relative risk zone, we started with horizontal because the exposure is along the horizontal. But in this case, we are starting with vertical because the outcome is along the vertical. Now, out of the 50 that are exposed, that developed lung cancer rather, how many were smoking? 45. So if you want to calculate, you cannot calculate risk here because. So what you can do is just for you to calculate the odds of smoking among the people that have the lung cancer. Odds of smoking. Even the risk of smoking, people have already smoked in the past before they develop it. So you cannot have, so based from the logic, the way we have conceptualized it, we know that if you want to say what is the probability of smoking, this for smoking, it will be 45 over 50. What is the probability of not smoking? 5 over 50. If you divide 45 over 50 by 5 over 50, when the time to change the numerator and denominator of that 5 over 50, it will be 50 over 5. And 50 will cancel 50. So it will remain 45 over 5. So here the odds will now be 45 over 5. You know the odd is probability divided by probability of event over the probability that event is not occur. Event over non-event. So at the end of the day, it will be 45 over 5. This you do the same thing for the people that don't have lung cancer, it will be 60 over 90. So if you look at it, 45 over 5, 60 over 90. If you look at it, put it together, if you look at that 45, it's A, say A. That 90 is say D. This 5 says C. This 60 says B. That's why it's just okay. Odd ratio is AD over BC. No, it's just a shortcut. By the time people solve it mathematically, they arrive at it's actually just, that's what they call it, cross product. You see a slide that is showing that is the logic. Now, we'll quickly go to the interpretation. Now, this is what so the formula has explained itself because there's no, you look at the formula, say relative risk A all over divided by A plus B, everything over C plus D. The odd ratio AD over BC. That's just the logic. Now, look at what I was saying about cross product. Because A, just A times D divided by B times C. Is if you work it out yourself. It's some people that work it out, they just, many people, when they look at, they work out something, it becomes mnemonics. Just give it to people, just cram it like that. But it's good not to cram everything, it's good for you to know the logic behind it, so that we don't lose stupid sometimes. Now, let's quickly look at the So the calculation of the confidence interval, the formula is there, but it's a little bit complex. I don't want to bother you with that, but when you run it with SPSS, it gives you confidence interval. So I want us to look at that and know how to interpret the confidence interval. Look at the first one. This is the odds ratio in relative risk 10, and the confidence interval between 3.85 to 25.965. So you can see that the confidence interval did not cross 1. I will explain that one further. The same interpretation with the result. Look at the odds ratio. Odds ratio, the one we just calculated now should be 30.5. Look at it here. Look at the confidence interval. How do we interpret confidence interval? Now, okay, before we talk about that, let's first of all look at we have discussed it before. Let's look at the way the result comes out. What you have just done now is to compare risk between two groups, or compare odds between two groups. Odds ratio is a proxy to relativity. Proxy in the sense that when relativity cannot be calculated, it's standing. It's not the real issue. Relativity is the issue, but it's easier to calculate. And that is why most study, even meta-analysis, because most of the study they publish is odds ratio they calculated. So most meta-analysis come out with odds ratio also. Let's look at it. If the risk, you compare two risks, if the risks are the same between the exposed and non-exposed, and you compare by dividing, if they are actually the same, when you divide the two, it will be 1. So what it's telling you is that if the risk, the disease, is the same among the people you think are exposed and the people you think are not exposed. If it's the same, the odds ratio is 1. It means that thing you call exposure is not an exposure. It doesn't have anything to do with the disease, because both people that are exposed, people that are not exposed alive, they have the same risk. So when the odds ratio or relative risk is 1, the disease, the exposure has nothing. There's no relationship, no association between what you call the exposure and the disease of interest. Now, the other one you can see is that it may be greater than 1, it may be less than 1. If it is less than 1, imagine you have already put something as numerator, and you put it, these are the risks among the exposed as numerator, the risks among the non-exposed as denominator, and I discovered that when you calculate it, it's less than 1. It means that the numerator is smaller than the denominator. That's why it will be 0 point something. If you divide something, if it's 0 point something, it shows that the numerator is smaller than the denominator. So if the numerator is smaller than the denominator, it means that the risk is smaller among the people you think are exposed than the people you think are exposed. In that sense, that shows that that particular factor is actually protective. It's not causing the disease. It's working. It doesn't cause. It's even protecting against the disease. That is when the odds ratio or the relative is less than 1. What you are may be interested in is where it is greater than 1. When it is greater than 1, it means that numerator, which is the risk among the people that are exposed, is bigger than denominator. That is why when you divide it, it will be greater than 1. So whenever the odds ratio relatively is bigger than 1, that shows that yes, the exposure is causing the disease. Now, having established that, let's look at when will you say significant? Because for the fact that you get your answer and say yes, it's greater than 1, doesn't mean that it means anything. When will you say? Because something can be greater, it may be 1.1, 1.2 can be anything, even just small, greater than 1. Doesn't mean, even it can be big anyway, but doesn't mean that it's significant. How do you judge that? You know, there are 2 type of inferential statistics that we usually use. Though there are 3 types, but we usually use 2. We use hypothesis testing, which ends with p-value. We use confidence interval. We do the third one that is not popular, but it has been there for long, is Bayesian method. But now, here, we are looking at confidence interval. You know, the logic behind confidence interval is that when you calculate anything you calculate, either mean, mode, median, percentage, or relative risk, or odds ratio, or sensitivity, or specific, think of anything you calculate with your sample. That is statistic. So I want people to subscribe for our material. You get all our former video. We are talking differentiate between statistic and parameter. They are well laid out there. Those are fundamental issues. So anything you calculate is statistic. But the real issue you are interested in is this parameter is in the population. Whatever you are supposed to get, if let's say you use the whole population to carry out your study, whatever you get is the parameter. That's the real thing. Like for example, if you calculate odds ratio now, you say this is odds ratio 2.3. It's statistic. But if let's say, because it's statistic because I calculated from the sample. But if let's say I didn't take sample, I just studied the whole population, no matter how many they are, and get that odds ratio. Yes, that odds ratio will be parameter. That will be the real thing in the population. But because we don't have access to the whole population because of logistic issue and many other things, and not study the whole population in many situations. It's only a few occasions when the population is finite to study the whole population. So you usually take sample. When you take sample, when you calculate your odds ratio now, it gives you a value. That value is an estimate of parameter. That statistics and estimate of the parameter. There is a point estimate in the sense that you know that in as much that you have not taken the whole population, there's no way whatever you have calculated will be equal to what it should be in the population. And there's no other way for you to know what will be in the population. You know that it's not the same. You yourself know that it's not the same because you have not studied the whole population, it cannot be the same. But how close is it? So the confidence interval, the intelligent people came with confidence interval. What they do is that it gives you a level of assurance that, okay, if I have this value, I will now calculate a range of value. The range of value we have lower and upper limit. The lower limit will be smaller than what I've calculated. The upper limit will be higher than what I've calculated. That range with level of confidence, 95% usually used based on the way we calculate it. You are 95% confident that in the population, the odds ratio will be between this and this. That is confidence interval for you. So that is confidence. It gives you a range of value. But how do you know that this range of value is significant? Now, you know that we have already talked. Look at this slide. We already said that whenever the odds ratio or relative risk is 1, it means that there's no association between the exposure because it means that the exposure has the same, the burden of disease, is the risk of disease is the same in both exposed and not exposed. In that case, it's the same among both of them. Because you are divided there, it's the same value, it gives you 1. It means that the exposure has nothing, that factor has nothing to do with the disease. That is 1. It is when it is less than or greater than that you'll be talking. If it is less than, that factor is preventing the disease. If it's greater than 1, that factor is causing the disease. Now, whenever you now have, imagine you calculate your odds ratio relatively, and now give you a range of value, so to speak, a range of values as confidence interval, and now give you 0.7 to 8.9. It has given you a value. If you work on a mathematical scale, if you are moving from 0.7, you have to reach 1 before you cross to 2, before you can reach 8. So because what confidence interval is telling you is that in the population, any value within this range of value can go. It can be, the value can be any value between these two ranges of value. So if you calculate your odds ratio to be 2.3, and somebody now say that, and the confidence interval is 0.7 to 8 point something, in as much as for you to cross from 0.7 to that 8 point something, you have to cross 1. This pillar 1 is one of the things you have to. So what it means is that in the population,
The odd ratio can be 1. And you know that when odd ratio is 1 or relatively is 1, there's no association. So that is why whenever the confidence interval, the range of confidence interval of the ratio or the relative rate or odd ratio include 1. If it crosses 1, that is, if it is from 0 point something and something to something after 1, it is not significant. So it doesn't really matter. The odd ratio you have calculated may be greater than 1. It may be less than 1. It doesn't matter. So look at what we have on this diagram now. There are 4 pairs. This first one give you a range of value from here to here, and this one in the middle will be the real odd ratio or relative ratio calculated. They give you a range of value. But if you look at it, both the range of value and the odd ratio or relatively, they are less than 1. Both of them are less than 1. But look at this. The lower value is less than 1, the odd ratio is less than 1, but the upper value is greater than 1. You will see that the difference between these two now is that this one, the confidence interval does not cross 1. But this one, the confidence interval has crossed 1. Even though the relative, what you calculated is less than 1. So the issue there is that this one is not significant because the confidence interval has included 1. So in the population, you are 95% confident that in between here, and 1 can be 1. 1 is one of the possible values it can assume. So it is not significant. But this first one is significant. The only thing there is that the odd ratio you have calculated relatively is less than 1. It means that that particular exposure is preventive. For it to be less than 1, the numerator was smaller than the denominator. That is, the risk among the exposure, which is the numerator, was smaller. So that should have the exposure was protected. So let's come to the last one. You will see this one. You see the lower value of confidence interval is less than 1. The relative odd ratio is greater than 1, and the upper limit is greater than 1. So it has crossed 1. So it's not significant. But this one, everything is greater than 1. It has not crossed 1. So this one now, what this one means is that this last one, it means that, yes, it's significant, and the exposure is causing the disease because the odd ratio or relative risk is greater than 1. Because it's the exposed that is the numerator. For it to be greater than 1, that shows that the risk is higher in the numerator. That is the explanation for that. So when it comes to interpreting difference between means, it's different. That one is different. If it is mean now, we will be talking about the 4 ratio, odd ratio, relatively, hazard ratio. That is how to interpret the confidence interval. When it crosses 1, it's not significant. So even if the value can be greater than 1 or less than 1, doesn't matter. So for you to know if what you are dealing with is significant before you start making judgment, is to look at the confidence interval. Now, the relationship between this confidence interval and p-value is that if it's significant with confidence interval, it will be significant with p-value. Because if you set your p-value to be 0.05, 5%, your level of significance to be 0.05, 5%, your level of confidence will be 75 because 95% rather, because both the confidence level and the significance level, they add up to 100. So when you are talking of 95% confidence interval, so if it's significant with p-value, it will be significant with it. But the only thing is that the p-value gives just that one information that is significant. It doesn't give anything more than that. And that is why Lancet will not take it from you. It has no place in medicine. He said that p-value has no place in medicine. That he started with agricultural research in the early 90s when they dichotomized studies into significant and non-significant. So it's agricultural and industrial research that started that has no place in medical practice. So just note that, but you see that the confidence interval give you 2-3-fold information. The p-value give you only 1, that is significant or not. But the confidence interval tell you one, it give you the estimate, the odds ratio, the estimate. Then now give you the range of value within which you can find the value. And you can also know if it's significant or not. Somebody is making noise. Please, somebody should mute. A2 Ken, mute yourself, please. Not even mute. Yeah. Please be typing your question. Now, you will see the result we generated here. Now you'll be able to see for yourself. Like for the odds ratio 13.5 and the confidence interval between 5 to 35.9. You know that it's significant. It does not cross. It does not cross. And because it's higher, it's greater than 1. That shows that the smoking is contribute to lung cancer. The one for the relative risk, the same thing, is 10, and the confidence level is 3.8 to 25.9. You know it's significant because it did not cross 1. So before we round up now, we have about 3 slides to just go to explain to you. But that was how we stopped last time. So let me just explain it. Somebody is making noise. It's much other. We're almost through. Let me just explain this 3 slides. This one has to do with the relationship between odds ratio and relative risk. We have already established the fact that when the disease is rare, or the attribute of interest is rare, the odds approximate risk. That is, odds is close to risk. So the same thing, odds ratio will be close to relative risk. Now, A2 Ken, I mean, please, if you don't, I will just remove you. You're in public, please, let's behave as such. Now, if you look at this formula, you remember that A over A plus B is the numerator for relative risk. C over C plus D is the denominator. So when the disease is rare, the attribute is rare. If you remember, the A part, Michael, why are you writing on this slide? Maybe I allow you to, okay. If the disease is rare, remember, I want to show you that. You remember that the place that have the disease is the A and C. The no that don't have the disease are B and D, the cell. So if this is rare, compare with what you have at B. A will be small compared with B. C will be small compared with D. So A will contribute small to A plus B. B will contribute almost everything about the total there. The same thing with this one. C will be small compared with D. D will contribute almost everything. In that situation, you can as well rewrite the equation and say, instead of, since A is negligible compared with B, you just say A all over B. This one will be C all over D. And when you put A all over B divided by C all over D, it will change to AD over BC. When you change, the denominator, you not change it to times, D will come up, C will go down. So you see the formula for relatively become that of odds ratio when the disease is rare. That's how to prove it mathematically. And that is why when you are dealing with rare disease that you wanted to study with, you will have studied with cohort study. Cohort study is very expensive. If you go and waste money to study cohort study with rare disease, what will happen is that you waste money, you may not get any result because the disease is rare. You may not even see one case of disease in 40 years. But it makes sense to not gather anybody that just have the disease, do case control. The one you have seen, look for control for them. At the end of the day, the answer will not be too far, because when the disease is there, whatever you are going to calculate, which is relative risk for cohort study, it will approximately be close to the odds ratio you have calculated. You are going to calculate for case control study. Then look at this table also shows some things like that. This one is looking at prevalence of disease. So look at relative risk, prevalent in exposed, in group 1, which is exposed, prevalent in the group 2 that are not exposed. This is relative risk. The odds ratio will be this over this divided by this. Now, look at this first scenario. When in the exposed, the risk is 0.1. That of the risk in non-exposed is 0.05. It's half of it. So the relative risk is 2. The odds ratio is 2.11. When the burden of the disease, if it is 0.3, 30%, and is still in the exposed and not exposed, is still half of it. Of course, the relative is still the same, but the odds ratio has increased. Can you see? Look at it as because the way as the disease is increasing in the population, even though it's maintaining the same relative risk, distance between the exposed and not exposed. That's why you're having the same relative risk, because it's 2, because the disease double in the exposed than the not exposed. But as it's increasing, it doesn't affect the relative risk, but it has affected the odds ratio. The odds ratio is increasing. But you see that the value of the odds ratio also is closer to the that of relative risk when the disease is smaller. Can you see? Here is 2.11. Here now, as the disease is becoming more, 2.42, 3. Can you see? So when the disease, the relative risk is. Another way to prove it, in what we have done, if I may ask you, in these 2 examples we have given, if you look at this table now, they are talking about lung cancer. If you look at it, with the total people, 200. Out of the 200, 50 have lung cancer. The other one, out of the, what do I call it? Out of the 1,500, only 30 have lung cancer. Where will you say the disease is rare? You can say the disease is rare in this first year, because out of 1,500, I'm just used to compare. So when you have to compare these 2 scenarios now, the disease you can say is rarer here. In this first example, because 30 people have lung cancer out of 1,500. Whereas in the other one, how many have lung cancer? 50 out of 200. So it's commoner here. Then let's look at when we calculated their relative risk and odds ratio. Let's see what we calculated for both of them. Okay, for this first one, what we say is rare. Look at the relative risk is 10. The odds ratio is 10.474. Can you see? 10. The relative is 10. The odds ratio is 10.474. It's very close. Let's look at the other one. The other one that we say is commoner. The relative risk is 8. Odds ratio is 13.5. Can you see? The distance is much here. Because the disease is more here, the distance between the odds ratio and relative risk are wide apart. Why the other one, the disease is rarer than this one, the distance between the odds ratio and relative risk are very close. The last thing I want to say, still based on that, whenever, if the disease is 1, if the disease, the risk is the same among the exposed and non-exposed, that is, if the exposure, the factor, is not a factor at all, it doesn't contribute to the disease, both odds ratio and relative risk will be 1. 1, that is the only time they are the same. 1. But when their value moves above 1, that is, as the disease is related to the exposure is related to the disease. So as you have a value above 1, the value of odds ratio will be greater than that of relative risk. You can see these two examples we have used now. In the two examples, because the odds ratio or the relative risk, both of them are above 1, you see the value of odds ratio is greater than that of relative risk. Look at it. Here, odds ratio is 30.8, relative risk is 8.1. This one, odds ratio is 10.47, relative risk 10. So when the disease, the risk is greater than 1, the odds ratio is greater than relative risk. But when the risk is less than 1, that is, if that factor is protective, the odds ratio is less than relative risk. Can you see? And the reason is very simple. Because the odds ratio, just like the way it's related to the relative risk, it's related to risk. Risk has a narrower margin between 0 and 1. It doesn't move. The risk cannot go below 1, is 0, cannot go above 1. But we know that odds can move from 0 to infinity. Now, all relative risk also, though relative risk can be greater than 1, but it has a narrower margin. But odds ratio ranges from 0 to infinity also. So you will see from this, look at this diagram now. It's showing the relationship. This is the plot of odds ratio, vertical, relative risk, horizontal. Along the diagonal, at the 45 degrees is the one when the both of them, when the risk of the disease is the same, odds ratio and relative will be the same. Look at it. Can you see? 1 relative risk, 1 odds ratio. So when the risk is 1, both odds ratio and relative will be 1. They are the same. But when the risk is greater than 1, to the left side, odds ratio will be greater than relative risk. Look at it now. Let's trace this one, and this is relative risk 2.5. If you trace it up, where does it meet this green? Meet at more than 2.5. Can you see? Can you see? Trace this 2.5 to this green or any of them. It means so. The risk is 2.5, but the odds ratio, the relative risk is 2.5. The odds ratio is greater than, it's like maybe 3 or something like that. It's greater than 2.5. That is where on the right side, that is when the risk is greater than 1. When the risk is less than 1, look at it here now. You see that the odds ratio will be less than relative risk. Look at the odds ratio relative risk 0.5. If you trace it to this green, it's less than 0.5. That's just so the diagram is just showing the relationship between odds ratio and relative risk, because for a particular data set, you can calculate both odds ratio and relative risk. It's only the matter of you knowing the appropriate thing. It's only that if you are doing, you are not doing cohort study, you are not doing experimental, you cannot be talking of risk. You cannot say you are calculating relative risk. But the machine will give you, it has value, but it's only that it's just like there are something you can do, you not just do. And you can decide to do something, but you not just do because of your value system. This how can I do this? Not that it cannot be done, but you cannot do. So it's the same thing. So it can be calculated because both any data set has both relative and odds ratio. But it's just a matter of knowing the appropriate thing to do at that time. Now, lastly, I think that is we will not talk about that judging association. That one will come and we that come for workshop. But this is the last one I just want to show here. I said something the other time because of the way things are, the resources, the cohort study, case control study is cheaper. Cross-sectional study is cheaper than cohort study. All those, they are cheaper. So because of resources and because of maybe some diseases are rare also, most studies report odds ratio, not relative risk. If you do meta-analysis, you go to see, because most meta-analysis will report odds ratio because most of the study got this odds ratio reported. So some intelligence with a formula that if you calculate, you have maybe your meta-analysis, you have some you will get odds ratio, you can convert it to relative risk. The reason being that the value of odds ratio from what we are seeing now, we say that when the risk is more than 1, odds ratio is greater than relative. So odds ratio will overestimate risk. So if you are trying to do economic analysis, maybe you want to, for planning, you want to know the burden to lay for a particular project, if you use odds ratio, it may overestimate. It will not give you the actual burden of the problem. So that's why intelligent people, okay, you can now convert it to relative risk, this formula. I think we stop here so that we can entertain questions. Yes, let me see the charts if we have asked question. Okay, I would like to have from sir, you can mute everyone from your hand, please. Let's start, sir. Yes, I was trying to do that. Then Ayo Kumi Sowade, okay, welcome. Good evening. Can you mute everyone from your system? Somebody say that. Okay, well done. I will be grateful if we get soft copy. We'll discuss that because everything is available. Then thank you so much. Kindly send soft. I thought it's question. Thank you, sir. How do you set the range for confidence interval? How do you set the range? There is a formula, and if you run your analysis, bring it out also. So it's another, talking about calculating is another ball game, but is a formula. Is what is just there that it involves standard error. When you calculate the value, the standard error, from which you'll be able to calculate your confidence interval. Then, you know that you set it. It's not that you set your confidence interval. You calculate 90. Okay, maybe what you want to ask was that if you set your level of significance, you have already set your confidence interval. If you say your level of significance is 5%, your level of confidence, your confidence interval is 95%, because the confidence level and level of significance, they add up to 100%. Thank you, sir, for the lecture. How do you set the range for okay? Thank you for the lecture, please. Can you briefly explain how to interpret confidence interval for different mean? No, we will not explain it here because we don't have time. We have another one for it. If you in a video also, there are workshops. We have talked about t-test, or you will see a lot of video there. I even explain it. Great discussion. Okay. Thank you, sir. Great leg. Okay. Thank you.
Can I come in at this? Can I come in at this?
You can come in, sir.
Can I come in?
Yes, sir. You can come in, sir. Go on, sir. I'm listening. Unmute yourself and talk.
Can you hear me?
Yes, sir.
Can you hear me now?
Yes, we can hear. Even then.
Some of my students are going. Some of my students are going for exam. I hear.
Yeah, okay.
And the time is very short.
I've seen my friend.
The time is very short for them to begin to. The time is too short for them to go and start going through the video. So if you can just tell them that in other situations that the moment it crosses 0, just a minute, it will be okay for me.
Okay.
Just a minute.
Okay, no problem.
Okay. Just a minute.
Okay.
Because they don't have in time to go and start going through all the videos before that time. Okay, thank you.
Okay. Okay, no problem. Any other question? I will do that. Any other question? Okay, please, I need this. Okay. We will talk about that soft copy. Yes. Let me quickly explain that. So I want to share the board. You know, in this case now, what we look at is odds ratio or relative risk. Because it's all about division, dividing the risk, one group by the risk, the other group. So if the risks are the same.
We can't see you.
No.
We are not seeing.
I think I shared this. I mean, I've not written anything. I just share it.
Okay.
I've not written anything.
Okay.
Yeah, it's just whiteboard.
Okay.
I wanted to. I'm just explaining
Okay.
something. Yes. Okay, maybe before I share it, I will share it. I want to write something there, but I just want to. Maybe before I do that, let me just explain. So because this one involves denominator and numerator. One is denominator, one numerator you are dividing. So if the risks are the same on both sides, of course it will be 1. That is why 1 is the point. So the 1 just means that there is no association. We have already established it. That's why for relative and odd ratio is 1. But for difference between means, because you are comparing 2 means, if something, the blood sugar among one group is 60 and the blood sugar among the other group is 60, when you remove them, it will be 0, because mean is about difference between 2. So that one is about subtraction. So trying to look for the difference there is subtraction. For odd ratio and confidence and relative risk, to look for the difference is by division. So if they are the same, it will be 1. But this one for mean is by subtraction. If they are the same, when you subtract 1 from it will be 0. And that is why that one is 0 instead of 1. I will draw it now. So let me just draw it. Okay. Yes. Imagine you have a scale. You know this one is different from the other one. You have a scale of 0. Yeah. This is 0. This is 1, 2, 3, 4. I'm just like calibration now, and so on. This will be -1, -2, -3, -4, and so on also. Imagine if there's a confidence interval, maybe you remove one from the other. It ranges from here to here, and the value is here, just like the other one. And there's another one, is from here to here, and the value is here. Another one is from here to here, and the value is here. And there's another one is from here to here, and the value is here. You see, this first one, if you look at it, this is 0, the one having like 1 now. Because you know that if there is no difference between the two, the difference will be 0. So if by the time you say the difference between these two mean, between those two mean is maybe 4. I now say, or maybe 2. I now say it's ranging from minus 0 point something or -1 to +3. Because you are telling us that in the population you are 95% confident that it can be any value from here to here, including 0. So 0 is one of the possible values, it could be 0. So since 0 is one of the possible value in the range, just like the other one 1, but this one is 0. So it's not significant because it can be 0. Because you know that whenever the difference between the two means is 0, means it shows that the two means are the same. It's not significant. There is no difference between the two. So now this one now, this first one now, what it means that everything is minus, even the lowest value, the real value you calculated, and the highest value is minus. What it means is that it's just simple. When you are calculating it, you are going to remove bigger value from the smaller value. Imagine you have two mean, 65 and 60. You now say 60 minus 65, it gives you minus 5. That's why. And if it's significant, the range of value will be from minus to minus. But it will be minus. So if you want to get your positive back, this one is easy. It's not even as deep. This one is even easier than the other one. You go and rerun it, and because the way the computer does is that the first one you put, it will remove the second one. So that shows that the group A or group 1 you put before you put the other one when you are selecting the selecting the group.
you put the small before the larger value. So go and change it. Put the other one before. It will give you exactly the same answer. It will now be on the positive side. And it will be from positive to positive. That is, if in this in a particular analysis, I know it, I get something like this. If I do it the way I've just said, I will get this one. Then now come to this. This one, the lower value is less than 0. The value calculated is less than 0, but the higher value is greater than 0. This one is not significant because this 0 is one of the range of the. Forget about even this one is minus, it doesn't matter. Then now, the same thing here. If what you calculated is plus, but the lowest is less than 0, once you see from minus to plus, it has crossed 0. It's not significant. But this one plus to plus. So this one, whether you get plus to plus for this one, is a matter of which one do you choose first. If I do it, you go and it doesn't change anything. The only thing is that if he give you, you do this one, it give you minus 4 to minus 2. When you do it here, it will give you 2 to 4. Can you see now? It's not 4 to 2. It will swap. As you are changing this, it will swap the you swap the figure. You won't just say because both of them are plus. You will not say plus 4 to plus 2. You know that it doesn't even make sense anyway. Now, if it crosses, if it's not going to be significant, whether it is plus, you get plus, or you get minus, it's going to range from minus to plus. You know that it should not be significant. I think I've explained it now. That's how to interpret.
Yes.
And the same thing with proportion. Mean and difference between mean and proportion. The same. Yes. Great. Any other question? Let me see.
That is chi-square.
Which chi-square? What happened?
No. I'm only trying to explain to them.
No, the one we just did.
I'm not talking.
Okay. Okay, that's
I'm only
it.
trying to explain to them.
So,
Yes.
any other question before? Because if I want to attend to some other issue people are raising here, I will off something so that it doesn't add to the volume of the lecture. I will stop recording before we discuss. But if there's any question, so that all the discussion is going to be recorded, so that people can benefit from it later. Any other question? Like it's very self-explanatory. It's explicit. Okay. If that is okay, let me just off